Hello, it's me once again. I know it's been a little bit since my last upload, but oh well. But I should hopefully be getting back into uploading a little bit more often, so I have nothing else to say. Today I'm going to be teaching you how to use binary. First off, you might be a little stuck. What exactly is binary? Binary is a base-2 number base, which basically means some math bullshit. I'll probably put it up here and some explanation. Not entirely sure what I'll do. And if you don't know, binary consists of just ones and zeros. If you stumbled across this video, or either that you're subscribed and are watching, you might be wondering why I'm making this video. Main reason is probably I'm gonna be referring to binary in future videos, since I plan on doing tutorials for different programming languages, so I might refer back to this video in the future. And also, binary is not hard to learn. It's fairly easy. I didn't know how to use binary or read binary at all until a friend taught me in like less than 5 minutes. So let's have an example usage of binary. And a good way that I can see of learning how binary exactly is useful is using light bulbs. So let's say our computer has 10 light bulbs, and we just want to see the result of, let's say, 2 plus 2. Well, if you haven't graduated elementary school yet, the answer to 2 plus 2 is 4. And of course, in order to show that we have the number 4, we would just light up 4 light bulbs. Now, let me ask you how we would solve this. What is 9 plus 10?
21.
You stupid.
No, not.
Exactly, 21.
You stupid.
However, let's say our computer can't expand, and we can only have 10 light bulbs. That's a bit of an issue, but if we use binary, we can actually use just a few of those lights to actually make the number 21. So how does binary exactly work? So if you don't know, 1 means on and 0 means off. Each 1 or 0 when you're reading binary is called a bit, and whenever you're reading binary, you're going to be reading it from right to left, much like if you were reading a manga. So of course, we normally understand the number 1 in binary is just the number 1. Now, in order to get the number 2 in binary, we write it like this. Now you might be a little confused because you might be thinking that's 10, but that's actually 2. Now remember, we're reading it from right to left, so the first bit is always going to be the number 1. The following bit to the left of it is going to be the number 2, and if you remember, 1 is on, 0 means off. So in this case, the number 1 for number 2 is on, so we count 2, and the bit for the number 1 is 0, so it's off, so we don't count it, thus meaning 1 0 in binary is 2. So in order to solve the whole 9 plus 10 in binary, it would look like this. And of course, you can always use larger numbers, but of course you're gonna have to use more bits in order to do so. Can you easily convert a integer, like for example 14? Can we convert it into binary? It's fairly simple actually. You're basically going to be dividing whatever your target number is, so in our case 14, and we're going to divide it by 2. And once we divide it, you know that 2 fits into 14 7 times, and the remainder is 0, and we count the 0 and add it to the right. So then after that, we have the amount of times that 2 fit into 14, which was 7. So we divide 7 by 2, and of course with that we get like 3 point something something something, but the remainder of course is not 0, so we count it as a 1, so we add that 1 to the left of that 0 that we put for the binary. And then of course we have 3, we don't count decimal, so we just have 3 divided by 2. That gives us 1 with a remainder of some other mess. Remainder is in 0, so that's 1 added to the binary, and we have the 1 divided by 2, which would give us 0, and of course some other junk which the remainder is not 0 of course, so that's also a 1. So that means 14 in binary is 1110. And of course it's super easy to convert it back into our readable integers. So in order to convert it back, we need to split up the bits. So in this case, whenever we're converting it back, we're going to read it from left to right. Now remember, since it's base 2, we're going to be using the number 2 a lot here. So we have 2, and then we start off with 0, so 2 times 0, and then plus whatever bit it is that you're at, which in our case is the 1 at the very beginning. And of course 2 times 0 is 0, plus 1 gives us 1. Then after that we have 2 times 1, because that was the result of our previous equation, plus 1, which is our next bit, gives us 3. And then of course we do the same thing, 2 times 3, which was the result of our last equation, plus 1, which is our current bit, gives us 7. 2 times 7, and the last bit is a 0, so we don't do anything special with it, which gives us 14. So in short, binary makes it a lot easier for computers to make some super large numbers without taking up a bunch of physical space. Of course, it's easier to read once you get to learn binary. You can create some large mass like this. And of course, binary is super easy to write, as it's literally just a line and a circle. If you found the video helpful at all, please give me a subscribe, or even like the video at least. Give me your thoughts on it. I probably missed a couple things, which I wouldn't doubt it. Thank you for watching, and I'll see you in another video. Bye bye.
Now listen! That's called motherfucking—
Very useful information, my fellow.
Phone close, phone show, need a phone hoe. Phone money, phone honey, sipping phone foe. Phone show, blow the glow, never said that. Staying low on my toes, I'ma get that. It's getting serious.